Hello, this is Dr. Mears, and today we are going to be learning about angles of elevation and depression, bearings, and area of non-right triangles. So first, a real-world problem. Let's just review what we have done in the past videos. A tree casts a shadow of 10 meters when the sun is at an angle of 40 degrees to the ground. How tall is the tree? I was getting trees actually cut down, and I was like, ooh, I should do a problem with trees. So this is very relevant to what I experienced this past weekend. Okay, so let's look to see what's going on in the picture. So we have the sun is at an angle of 40 degrees, so it's hitting that tree of 40 degrees to the ground. So it's hitting that tree, and here's that little sun stream. So here's our angle measurement. And the tree is casting a shadow because the sun's shining on it. So the shadow, so this part right here is going to be 10 meters long. Let's label what we have. Remember, what do we have? So we have the angle. Remember, across from the angle is the opposite, O. We have 10. Remember, that's our adjacent. And we have our hypotenuse, which is across from our right angle. If you would like, I could write down, remember we went over SOHCAHTOA, S-O-H-C-A-H-T-O-A, where we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I cannot tell you how many times this has saved me when I was learning about sine, cosine, and tangent. Okay, so what do we need to solve for? We need how tall is the tree. So we're looking for O. We have no idea how tall this tree is. So the information that I have is A, and I'm looking for O. So who has O and A in it? And you're right, it's tangent that we're going to use. Lucky tangent. So tangent of theta equals O over A. So let's put our information in. I have the angle, tangent of 40 degrees. Remember, this is theta. Theta is our angle, equals, we don't know what O is. And I'm actually just going to use op here, opposite. I don't want you to think that this is a 0, so we're looking for the opposite side, so that's why I'm just going to use opposite. And then we're going to be substituting 10 in. You could use X here if you want. Anything works. I just didn't want to throw another variable in at you. Okay, how do we solve for this? We're looking for the opposite side. It's being divided by 10. Let's undo the 10 using inverse operations. So we're going to multiply times 10. We're going to take our calculator out and turn it on. We're going to press 10, and then our tangent button is right here, tangent of 40 degrees, making sure you are in degrees, and we're going to get 8.39. 8.39 is 3 significant figures. So 8.39, that is our opposite side right here. So the tree is 8.39 meters tall. Yay. Okay. So that's just a little review of our first world problem here. Okay. Let's learn about different types of angles. So there's the angle of elevation and an angle of depression. So let's say that you were just standing and you were just looking straight out. This is your horizontal line. From whatever your horizontal line, for us, it's at eye level. Sometimes it might be from the ground. It could be ground level. But this is your horizontal 0 line. If you look up, that is an angle of elevation. Angle of elevation. If you look down, that is your angle of depression. So up is elevation, down is depression. Let's see what we're going to do with this and our problem solving. So we got Rondo, he's flying a kite, and the kite string is at an angle of elevation of 60 degrees. If Rondo is standing 30 meters from the point on the ground directly below his kite, find the length of his kite string. Let's fill some information in. First, the kite string is at an angle of elevation. So here we go. We got this angle of elevation, and this is going to be 60 degrees. Okay. Rondo is standing 30 meters. So here's our 30 meters from the point on the ground directly below his kite. So I'm hoping that you're seeing our triangle come to fruition here. And here's our right 90-degree angle. Okay. Find the length of the kite string. So we don't know what this is. All right, let's fill out your information. We have the 60 degrees. Opposite side, opposite. Adjacent side, and now we know what we're looking for. We're looking for the hypotenuse. So what do we have? We have the adjacent and we need the H. So A and H. So we come back up here. Who's A and H? Hopefully you said cosine. Cosine is A and H. So we're going to go back down here. Cosine of theta equals A over H. All right, let's put the information in. Cosine theta is our angle measurement, 60 degrees, equals 30, that's our adjacent, over, we have no idea what our H is. We can just use H, that's fine. All right, let's get H. Let's multiply by both sides. Perfect. So H times cosine of 60 equals 30. Divide by cosine of 60. Divide by cosine of 60. H is going to equal. Now, whoops, I'm sorry. Can we do this without a calculator? I hope you said yes. I did. I hope you said yes, we could do it without a calculator, because we know what the cosine of 60 is. First, let's do it with a calculator. Let's get the answer first. We know the calculator is always going to work. Okay. So we're going to do 30 divided by, here we have cosine, and then of 60. And we're going to get, 60 degrees. Wow, pretty cool. Not 60 degrees, my bad. 60 meters, because we're not doing angle measure. 60 meters. So the length of the kite string, this is 60 meters long. Length of string is 60 meters long. Sweet. Okay. Now, let's just look at a little side note over here. 30 divided by the cosine of 60. So let's say I didn't have a calculator, or you got to that calculator part, non-calculator part on any test. So what would we do? We would need to know what the cosine of 60 is. So going back to our trigonometric ratios here, we would locate cosine of 60. So we're going off of this triangle right here, where these ratios for a 30, 60, 90 degree triangle, it's always 1 square root of 3 and 2. Over here, it's always 1 square root of 3, 2 for a 30, 60, 90. Those numbers won't change. You could have multiples, so we could have multiplied like 2 times 2 times 2 times 2, but when you reduce it, it's always going to come back to those numbers. So what is the cosine of 60? You would have to memorize that it would be 1/2, or remember these numbers, 1, 2, square root of 3. 1, 2, square root of 3. See the little strategy I'm using? Okay, so cosine of 60 would be 1/2. And when you divide 30 by 1/2, you are going to come out with 60, which is exactly what we got using the calculator. So 2 different ways of doing it. Okay, let's go to our next part. Bearings. Yay. Okay, bearings. We are getting into what looks like the coordinate plane, except we're going to label this north, east, south, west. I do not like that N. Let's make that N better. N, there you go. Okay. Bearings. A bearing is used to indicate the direction of an object from a given point. So, if we don't look at that one yet, take that one out. Okay. If we start north, okay, and let's say that if we start north and we just go north to east, right here, that's going to be 90 degrees. Okay. If we do east to south, we have another, and it's looking like a heart and not a circle, everybody. 90 degrees, okay. If we went from east to south, we're doing another 90 degrees. From south to west, 90 degrees, 90 degrees. So each of these 90 degrees, 90 degrees, 90 degrees. How many do we have? We have 4 of them. There are my lights again. They're going. Okay, I caught them this time. So if we add all of these up, 90, we have times 4, that equals 360, 360. And that makes sense because I just made a complete circle, everybody. I started from north and I went all the way around and got back to north. So That makes sense. All right, let's look at some different types of bearings. So we have this diagram right here. Okay, 240. So let me just show you where 240. I don't know why you need my keys. Okay, so 240 would be starting north, going all the way past east, past south, and ending up at this point on A. That is 240 degrees. You can write it like that. Or, see the 60 down here? Okay. What we needed to do to get to the 60 is we could have started at south, gone 60 degrees towards west. So we could write just this little 60 degrees as south, 60 degrees west. Or we could go a whole 240. Notice there's no letters in front. That's because we started north. So when you start north, start from north, you don't need to write those letters. But if you're starting from south and you're going west, you have to say where you start and where you end. Now, even on a compass is always pointing north, right? So that's because that's usually where you start from. So that's why we don't need these in the front or the back, because this, you just know that you're going from north. But here, this tells you where you started and this tells you where you ended. Okay, so hopefully you understand that. If not, call me over. But what are we going to use this for? Okay, let's do this example. Nina runs 5 kilometers on a bearing of 120 degrees from the start. How far south has she traveled? So let's put some numbers in this diagram. So it says from the start, north, east, south, west. What's the start? The start is north. So if they don't tell you a different start point, if they just say from the start, we're starting at north. Okay, so she's here. And she is running 120. So we go here. What is that, everybody? Yep, that's 90 degrees. Okay. We need, let's look at our calculator. Clear, on. Okay. We need 120. So she already went 90. She has 30 more to go. So we're just going to keep going over here about 30 more degrees. And I'm going to draw a line because... So this inside here, this was 90 degrees. And then once she passed east, she needed to go another 30 degrees because she needs 120 in total. That's where we know where to stop, okay? And so here's our point. Here's Nina. Yay, Nina, good job. And she said 5 kilometers. So this line right here is 5 kilometers. Okay, how far south? So where's south? South is down. I'm hoping that you're going to see that I'm starting to draw a little nice right triangle because we need to find how far south or how far down she went. So that's what we're looking for here. If you're having trouble lining this up, just call me over if you're in my class. If not, I'm sorry. Maybe rewatch the video. So we're looking for how far south. Let's bring out our trig ratios. Okay, what do we have? We have this 30 degrees. What's opposite? Yup, the opposite side. Okay, this is our adjacent side. The side opposite our 90 degrees, that is our hypotenuse. So we have O and H. So let's go back to our SOHCAHTOA, who's O and H. So we're going to go back here. Remember these trig ratios? If you didn't watch my videos before, here they are. You can write them down. So which one of these has O and H? And you're right, it's going to be sine. So we're going to be doing sine of theta equals O over H. Let's fill in our information. Theta is 30 degrees. Sine of 30 degrees equals, we don't know what O is. We do know what H is. H is 5. Now, I'm just going to put a little opposite in there. You could put If you wanted to use X, everybody, you could. But I didn't want you to think that was a 0. They get mistaken. I guess I could have put a little slash through it. But it is that opposite side that we're looking for here. Okay, how do we solve? We have to undo the 5. So let's multiply both sides by 5. We can do that in the calculator, so let's do that. We have 5 times sine of 30 degrees, and we're going to get 2.5. So this is 2.5 equals our opposite side. So she has traveled 2.5 meters south. So this would be 2.5 meters. Sweet. All right. Now, yes, you know what I'm going to say. Could you have done this 5 sine 30 without a calculator? Yes. It's going to be 5 times, let's figure out what the sine of 30 is. Now, if you remember 30, 60, 90 degree triangles, their measurement sides are going to be the same. So here's our 30, 60, 90. Remember 1, 2, square root of 3? So sine of 30 is 1/2. So we could have put in here 1/2. And 5 times 1/2 is 2.5, which is the same as what we got with the calculator, but except we don't need a calculator to do that if you know your ratios of your 30, 60, 90 or 45, 45, 90 triangles. Okay. Last thing for this video, and that is going to be the area of a triangle. We know switching. Now switching, we're going to be switching, so hold on to your hats. We know that the formula for area of a triangle is 1/2 base times height, where B represents the base and H represents the height. Base and height meet at a right angle. So here's our right angle, here's our base, here's how tall, here's our height of the triangle. So and it meets at this nice right angle. So our area would be 1/2 times 13 times 9. And if you did that in the calculator, you would have got 58.5 kilometers. All well and good. That would be the area, the inside of this triangle. All right. But what happens if we don't have a right triangle? What happens if our triangle looks like this? That is not a right triangle, everybody. Well, I can tell you, sine can help us out. So the area of a triangle can be found by using area A equals 1/2 times A times B times sine of angle C. When you see this, a capital letter, everybody, a capital letter, this represents an angle. C is their included angle. It's in between. These lowercase letters, these are side lengths. And it says it here, 2 sides. So if you like to write little arrows there, you can. It is included in here. So what do I mean? Okay, we have 2 side lengths. Either one could be A or B. I'm just going to label them A, and this is going to be B. The sides have to be joined by the angle. See how this angle is in between sides A and B. That's how it has to look. It can't be out here. It can't be out here. It has to join the 2 sides together. That's what it means by included. It joins, it brings the sides together. Okay, so let's substitute it in. So we have 1/2 A, 5 times 5, B, 8, sine of the included angle, 75 degrees. Area equals, you could put it in the calculator, just like you see it, everybody. 1/2 times 5 times 8 times sine of 75. Just like you see it, checking it over, everything is good and well. Enter 19.31, so let's go 19.3. 19.3 centimeters squared. And I forgot something, kilometers squared. My bad, everybody. You might have picked that up because it is area, so it's 2 dimensions, so squared, okay? And it is area, 2 dimensions, so squared. So the area of this whole triangle is 19.3 kilometers squared. So now we have a formula using our trig ratio sign to be able to get the area of a triangle that doesn't have a right angle, which is so cool. You can use this for anything, but you just have to remember these two sides have to be joined by that angle. That's the hint. That's the kicker, okay? All right. This has been, boy, we did bearings. We did area of a triangle. We did some real world problems with angle and depression. I think depression, we did elevation. We did elevation, I mean. We did a lot. Okay. This is Dr. Mears. Thanks.